Okay, had a question about, this is question 1B, I think, from CorbettMaths, the Advanced Simultaneous Equations worksheet. So we're solving for the two or however many locations that these equations intersect. Remember, this is a parabola and the other one is a straight line, so there's potential for these two lines intersecting at 2 points. All right, what we want to do, since these are both set equal to y, we can just set the two expressions equal to each other and solve from there. So I'm going to take x squared plus x minus 14 from that top equation and set it equal from the bottom equation, x minus 5. All right, from there we want to solve by setting everything equal to 0. And the question came about because the confusion for this person set in when these x's actually cancel out. That's okay, we can still solve for 0, it just might look slightly different. And then from here, I want to add 5 to both sides. Remember, you group the values together, so those x's went together, they canceled each other out, and then these integers also stay together. So I added 5 to both sides, these cancel out, everything on the right side turns to 0, just like I wanted to. And then I'm left with x squared minus 9. Okay, typically we've been solving these by factorizing so far. You could use any method. You still are able to factorize this because it is a difference of squares. It's a squared term minus a squared term. So remember, when we have a difference of squares, take the square root of this number, which is 3. You have 1 plus and 1 minus, and then fill in your x's. All right, and then we just need to solve. So I'm going to basically just flip the signs of these. X would equal a minus 3 here, and a plus 3 from that second equation. So I have my two values of x. So as it turns out, it looks like I have two intersections. But don't forget, we need to then solve for the y values. So I have my two x values. The first one was minus 3, the second one is positive 3, and I need to find the corresponding y values that go with them. I usually will use the linear equation for this bit. I just find it a little bit easier. So for the first one, if x is minus 3, y would be negative 8. And the next one, if x is positive 3, I don't know if I said that correctly earlier, y would be minus 2. Okay, so you have your two coordinate locations where the graph, both of the graphs will intersect. Okay, so when we're set equal to y, just remember you can set them equal to each other. Don't worry if the x's cancel out. Even if that were the case, you could still, if you were unsure that this was a difference of squares, you could have used the quadratic formula or completed the square. I know all those things are quite a little bit more tedious than factorizing. However, you do have many different ways to solve, so don't let that trick you up if your x's cancel out. Okay, good luck, keep practicing, and let me know if you have more questions.